My name, as you can see, is Billy Korando. I'm a Java developer advocate with this small company that we do a little bit with Java called Oracle. And you can find me on the Bird app on Twitter at Billy Korando, where I spend a bit too much of my time. And this is Taking Off with JDK Flight Recorder. So if you haven't heard of JDK Flight Recorder, I've only heard a little bit about it. Well, this is a presentation for you, as we'll kind of obviously get started 101 course into using JDK Flight Recorder. And if you've already used it a little bit, we will also cover on maybe some more advanced concepts or even actually some new things that have just been added to JDK Flight Recorder in some of the recent releases of the JDK. So important information, as one was asking, the link to this presentation is at the link here off of my GitHub pages. So if you want to check anything out, get any sort of links or anything to it, you can find it on this page. Definitely feel free to reach out, again, at Billy Korando. You can shoot me a DM or just, ping me directly and publicly on Twitter. Or feel free to email me at billy.korando@oracle.com. But also, feel free during this presentation at any point to ask questions. Again, the back end of this presentation is, or after this slot is lunch, so we're, a bit more time is allowed. So yeah, definitely ask questions. I'm here to help you learn about JDK Flight Recorder, so ask any questions you can think of, and I'll try to answer them. Not going to pretend to know everything about JDK Flight Recorder, but I've learned a few things over the past 8 or 9 months as I've been working with it a lot more. Also, though, if you do leave with an intense desire to know more just about Java in general, I'm on the the Java Platform Group Java DevRel team, and we last year with JDK 17 we launched dev.java, and we have a lot of great tutorials on that site. Also links to community events of course, like Jconf itself, or local Java users groups like the Great Chicago Jug here. So definitely check that out. Insight.java can be a really great source for learning about what's happening within the OpenJDK. We have a lot of great interviews and articles from the OpenJDK developers. Check that out. And we have our YouTube channel as well, where we publish our podcast, recordings at least, and then you can also find them on any normal podcast app, newscast. I do a weekly, about 1 or so minutes video on various Java topics. And also my colleague Jose does Jconf, where he does a deep dive on various Java topics as well. So great opportunities to learn more about Java. So with that said, what's the agenda? We're first going to start off with just getting some background, some level setting on what JDK Flight Recorder is. And then from that, the rest of it will actually really be all about a live demo, and where we can walk through things, and by any means, again, at any point, ask questions, and we can kind of, choose our own adventure, as it were, if needed. So what is JDK Flight Recorder? And kind of from here on out, I'll be primarily referring to as JFR, because, well, JDK Flight Recorder is a lot to say over and over again, hence acronyms. So what is JFR? Initially, it was added into the, mainline Java build back in JDK 7, and at the time, it was called Java Flight Recorder. So if you've been hearing Java Flight Recorder, that was also previously correct, but in JDK 11, it was renamed, it was open source and then renamed to JDK Flight Recorder. So as of JDK 11, you no longer need a commercial license to use JFR in production. And one of the really nice things about JFR is it's directly built into the JDK, directly built into the Java runtime. You don't need to go out and get some sort of separate binary or something like that and add it into your application. Every release of at least Hotspot JDK build includes JFR. Now, there's also OpenJ9, and I don't think that includes JFR just because its internal is completely different from Hotspot. But the history of JFR goes back to JRocket days, and the reason, the purpose behind JFR was 2 parts to it. One was to be able to better work with customers. Customers would be like, oh, we're running into some sort of weird bug or performance issue or something like that, and that can be kind of hard to describe back to to JDK engineers saying what's going on. So they developed JFR so that way customers could do some sort of recording that would get information about what's happening within the JVM, what's happening within the application. And obviously that's a lot easier way of then addressing maybe what is potentially happening. And certainly also JDK engineers actively dog food with JFR when developing new features and stuff within the JDK. So like when there's new garbage collectors being added, like GDC or something like that, or they're working on improving G1 or anything else like that, they will use JFR to actually test and run performance and say like, okay, if we make this change, does it reduce memory footprint? Is it higher throughput or whatever it might be? So it's not just something it's like, oh, here we just send it out to customers and never really use it internally. It's actively used internally as well. So it's a lot more tested. It's a lot more refined. It's not just okay, here's customers and you will use that and we'll use other tools for ourselves. So just to get a little bit more under the hood, everything within JFR is what's called an event. So it's an event-based diagnostic and profiling tool. Definitely one of the key takeaways I want, hopefully everyone here, is that JFR has an extremely low overhead. When using the default settings, it's an overhead of less than 1%. So really you should strongly consider turning on JFR, in your production, all your production applications and pulling out recordings, because it can be very helpful for whenever that, weird production issue springs up, to be able to go to that recording and maybe see what is going on when it. So yeah, it's meant to be used continuously in production. And the JFR, it covers events both happening within the JVM itself, as well as, of course, the Java applications running on top of it. And of course, as I mentioned, the under 1% is based on using the default settings that come from JFR. And if you use some sort of different settings, that could obviously affect overhead. And we'll get into that a little bit later. And a little bit more under the hood, like I said, it covers both the Java runtime and the application. And the way it has such a low memory overhead or low throughput overhead is that it stores everything in memory and through local buffers before at some point that information has been dumped to what's called a JFR file, Java flight recording file. And it's like a very densely packed binary format just to minimize the amount of storage space it is taking up. As of JDK 17, there's over 150 different event types being covered. Things like system processes, what settings are being used, GC information, reading and writing from files, reading and writing from sockets, thread dumps, thread starts. It's covering a whole lot of different stuff. I think JDK 18 is up to like 160 some odd event types. And I think a few more event types were added recently here with JDK 19. So it's covering a whole lot of stuff. I don't know if I talked about it later. But also JFR can be a good way of getting yourself ready for the future of Java. So a really good example of that in JDK 18, finalization was marked for deprecation for removal. So at some point, finalization is going to go away. It's not going to be anytime particularly soon because it's been around for a long time, but with that is we also added a new event type that can let you know if finalization is occurring somewhere within your application, probably under some underlying library that you're using. And if you see that, you can then say like, okay, it's this occurring in whatever library that we're using, and you can then see about getting it upgraded or filing a ticket with that library maintainer to hopefully get an updated version that reboots finalization. So there's also good ways for within the future of Java as to how JFR can also help prepare you for that. So with that said, enough of the slides. Let's actually kind of get into what it looks like to use JFR actually working. So one way to start JFR is just when you start up your application. So with the Java launcher, there we go. You could do Java, whatever command you want to do, and then there's the XX start flight recording, and then this can take a number of other options. In this case, I'm just saying, hey, I'm giving the file name of the very descriptive recording. Not that I would recommend using something like that, but for this POC is well enough. And then I have it set up to where when the JVM exits, when I quit the JVM, it will then automatically dump that information into that recording file I named. And then from there, whatever else you want to do with your application to start it up. And for here, I'm simply using like a slightly modified version of the Spring Boot Pet Clinic proof of concept app put together by the Pivotal team. Or I guess not Pivotal, but the Spring engineering team. And so yeah, I'll just do a few things just to generate some stuff and behavior within the recording file, though actually really in many ways, just from starting the application up itself, will do plenty as well. So if I go ahead and stop this. So for analyzing a JFR recording, a really good tool for doing that is JDK Mission Control. It was also open sourced in JDK 11, and it actually used to be packaged within the JFR or within the JDK itself, but with JDK 11, it was moved out of the JDK. But it is a really good tool for just giving you like an overall overview, and it can also really dig down into what is happening within the application. So you can see here threads that are being used, memory usage as well, what is happening within a JVM. It can also, let's see, I think so. Yeah, JFR, like, it will tell you like which garbage collector you're using. Like in this case, I'm using G1, like what the heap size and all that stuff was set to. So it can give you pretty detailed information as to what is happening within your application. Let's see, summary. And also so like here, like when garbage collections are happening, we have it started up, gets pretty high up in the heap. Then the garbage collections happen. You can kind of see how that pressure is building up, and then garbage collections happen and removing no longer accessible memory or objects from the heap. And if I was to actually change this to, you can also even see how this would be different if I were to use a different garbage collector. Do I? Yes. So I briefly mentioned it before. ZGC, that stands for ZGC, or Z doesn't really stand for anything. It is a newer garbage collector, and one of the things it focuses on is having the absolute minimum in pause times. Like it just exclusively focuses on the smallest amount of latency possible. If I go on and stop it, and then open up that file, we can see how the heap behaves much more differently compared to what we see here within G1. And then also if we look at the pause times, here like the pause times with G1, it's like 7 milliseconds, 6 milliseconds, usually it's going to be several milliseconds in pause times, whereas with CGC, its longest pause times is 43 microseconds. So that gives you an idea that it really has a much lower pause times. But this, obviously is a very simple demonstration, though, that those pause times are consistent with what you would see even in more heavy load. But this kind of can show you how it's like if you want to see how your application would behave with different settings, whether it's different garbage collectors or different amounts of heap space and stuff like that. JFR would be a really good way of demonstrating that. You would obviously want to have some amount of like, okay, we're printing it on a consistent load amount, so you have some sort of baseline to properly compare them with, other than me just simply clicking it around. But this can show you how with JFR, you can use it to compare different settings to see what would make the most sense for your application. rather than oftentimes, at least I know I would do it, just like the guesswork of like, oh yeah, if I set like the memory or heap space down to half of what it was, like it seems to still work, but I was just like guessworking as a developer without using something like JFR back before the time I really kind of got into this role of developer advocacy. So, yeah. Oh, and so one other thing that's also I really do like about JFR is, so I talked about how it's like it can always be on when you're using it in production, but it could be very easy to simply forget to have turned it on for whatever reason that might be. And so the concern then might be like, oh wait, we have one of our applications running in production right now, and it's been running there for hours, days, or whatever it might be. And then all of a sudden you're running into some sort of issue, like it's running out of threads or memory or whatever it might be. And it would be like, okay, well, we're seeing this issue. It only happens after some amount of time. It would be really annoying to then have to stop the application just to start JFR up again, and then have to wait whatever amount of time before maybe this issue would crop up. And it could be something that's super intermittent, and you just never know when it's going to happen. Well, luckily, you can actually start JFR on an already running application. So just ran that in the background. So in this case, this application is running on like process ID of 67119, though also if I was to do JPS, the Java processes, I can also get an idea of where it's running. And with that, I could actually start up JFR on an already executing application with the J command tool. So if I do J command and then the process ID, I can then go ahead and start up JFR on my already running application. Now, of course, anything that was running before, like all that information won't be captured, but from then on, all the information would be captured. And so before I was also showing how like I was running I set up to dump on exit to true. And of course, most applications, they're going to be oftentimes running indefinitely. You have like your web application, whatever, running. You're not often going to be exiting that. And when you do, again, it's going to be after probably some extensive period of time. You're probably often going to be running those for hours, days, or even longer. So you can actually run a dump on a running application as well. That is not what I wanted to do. And it even shows it here as well. It gives you a tip when I started recording it that, if I was to run J command and this, it would then dump it as well, the content of that. And so if I was to open that up, again, there's not going to be a whole lot in here since, most of the behavior of what I've been showing has been from what at startup. About the same if I was to open this up. We can go in here and kind of just see, the couple minutes of activity that occurred, which again isn't exactly a whole lot that happens. But also a lot of this stuff can also be pre-configured at startup. I'm only here at the start flight recording. I'm only showing just 2 of like the dozen or so different configurations you can set within it. And then there's also a configuration file, which I'll cover here in just a few moments, where you can also provide configurations on, like you can periodically dump based upon time, size of a recording, and other values as well. So it's not as though you manually or have to set up some sort of shell script to periodically tell it to dump manually like that. You can also set up JFR to where it can consistently set it up to dump information out at some pre-configured notion. Added, I believe it was in JDK 14. So also kind of right now, the way of getting this information out is performing a dump, and that can be somewhat coarse-grained way of getting this information out. And it may not always be useful for getting like live metrics out of your information if you want to have some sort of actionable thing on it. PS 9. Let me go ahead and kill this. Huh? Oh, yeah, that's right, yeah. Thank you. There we go. Perfect. Thank you. Yes. There we go. So added in JDK 14 or 15 was the ability to stream information out of JFR. And this simple example put together by one of the JFR engineers, it is using a Java agent to give a live look that's printed out to the console of what is happening within the application. Kind of what I was showing a bit on the JMC here, like it's showing like the amount of physical memory, the amount of heap, CPU, machine usage. All these are quite low because obviously I'm not doing anything on the application right now. But of course, this is a live look into the application. If I was to, split screen it, which may be a little bit difficult here, just it'll really goof up like what this looks like here. And it was to start putting load on the application, you would see these numbers move. Again, this is just a demonstration providing a dashboard, which, it's, a kind of cool look at it, but it could also be very useful. I know that someone was mentioning about how many of these presentations today were on Kubernetes, but if you were, for example, say using Kubernetes at your company, you could use this to say like, okay, how much of the heap is being used, and if it gets above a certain level, to then spin up a new container to, take off some of that load, or, of course, CPU machine usage, and so on. You could do that to change behavior to, spread out load, or of course you can use it to potentially send out alerts of like, oh, okay, we're getting very close to the max on the used heap, to then again, send out an alert like saying, hey, we're running out of memory here. You may want to do something. So these are some ways of how streams could be used. Now, how you use streams would also affect the overhead. So in this case, like it's using a Java agent, so that would have some impact on overhead. You can also do it through JMX. Of course, every time all that information is then being serialized before it's being published out, which again would have some sort of impact on overhead. So keep that in mind, but there's a bunch of different ways. You can also have it streamed to like a messaging service, in which case it will probably be a much lower impact on overhead, though you would also have to configure that messaging service to continuously get read from. So it is just all to say that if you're doing that, you do want to have at least some idea on how it might be, what information you're collecting, how you're publishing it, the format you're publishing, or the means you're using to publish it, could all have impacts on overhead. So you don't want, in trying to get this information reported out, all of a sudden have like 5 or 10% of your overhead being just devoted to that, because that would be at least somewhat self-defeating. So I also showed how we can use the JMC, Java Mission Control, JDK Mission Control, to analyze a recording. But there's also the JFR tool, which again is built into the JDK. So the JFR tool is a tool for analyzing results and also configuring and working with JFR, which is separate from the JFR, process itself. But yeah, for this, like just JFR summary, you can get a summary of like all the different events that have been fired within this application or within this recording from what was recorded. There's a number of different ways. So this can be very good if you already know kind of what you're looking for. Instead of having to go into JDK Mission Control and load that all up, you can use this tool to kind of get quickly from the command line, drill down to maybe exactly what you're looking for. So like here, I'm telling JFR to print out the events that match a certain event type. So yeah, for all the times like a thread started, it could show like that occurring. You can also do it by categories, and we'll show a little bit more by what I mean by event types and categories in just a few moments. But yeah, this is a good way of like, if you already kind of know what you're looking for, certain information, then the JFR tool can be a good way of really drilling down into that without having to continually load up recording files into JDK Message Control and then have to click through a GUI. Of course, that's fine if that's what you want to do. Don't feel like you have to always use a command line tool. But if you work with that pretty well, then that's a little bit easier. So far, I kind of mentioned how there's already 150 or so, like 160 now, predefined events, but you can define your own events as well. And it's really simple to do. It's not by any means a complex task to do that. In this example, all you need to do is extend the jdk.jfr event class, and I gave it, again, very descriptive, my event name. And from there, you can have several fields of information you can capture. The only allowed fields is string, class, I think there's one other, like thread or something like that, and then all the primitive types. If you put any sort of other type of field in here of information to capture, it'll just be silently ignored by JFR. So yeah, if I was to put like the integer class in here and stored some values, then it would just be silently ignored by JFR. But one really important thing also then is these meta description fields. Something actually when talking to the JFR team, they wanted me to kind of point these out more. So I was talking about like different categories, and like in this example, like I have like, okay, like I may be capturing PII, personally identifiable information, and like I'm also capturing business information, and it's critical. Using these kind of categories, whatever makes sense for your business, by no means does it have to be, these kinds of categories, can be very helpful then for when these event types might fire within your code to then actually properly get to them. If you're just using very coarse-grained of like, business name event type, then it might be kind of hard to properly drill down and find out that information is going on. You also can give like different labels to this. For this is how it will be presented then within recordings. By default, if you don't give it a name, then it will just use the fully qualified name of the class. So if I didn't give it a name, here it would be con.oracle.jfr .myEvent as a name that would show up in the recording. But since I'm providing a name here, my event name, again, super descriptive, that's how that event would be displayed and shown within the recording file. Now, to actually then use this event within your application, you would have to initialize the event. In this case, I just have the standard initialization, but you could, of course, have something being passed in at the event initialization if it makes sense. Then we need to call begin on it, and this begins the timer on it. And between that and then whatever you have, you would then need to call commit, and then that ends the timer and then commits it to the in-memory recording. While this does look a bit heavy within this code here, as far as performance-wise, it's actually extremely light. This begin and commit event, like they take only like microseconds to actually process. And if like this event, like I just decided to disable it to where it's not being captured by JFR, the JIT will actually basically remove the just-in-time processor, or will actually remove this code from it, so where you're actually not having any process time occur for it. So, maybe at some point, hopefully, maybe this can be a little bit cleaner looking, or of course, you can also kind of refactor your code to make it look a little bit easier, maybe have some sort of static factory method that just, does this all in a couple of lines. But it looks a bit messier than how it would actually perform in your actual applications. When setting these events then though, so like I said, there's the begin and the commit to it. And so as I mentioned, there is there's our default settings file included so there's a default settings file and a profile settings that's automatically included within the JDK itself, and then those files are located somewhere within your JDK installation. But of course, you can create your own custom events or settings as well, and this is what the, sorry about that, file looks like. It's clearly just an XML file, and it shows then like all the different event types and kind of have like different settings, like, okay, this one is enabled, and like, you know, different settings on how it would work. One helpful thing though, and there's many of them, so there's also like for example, a setting called threshold, and what this could be done is like, okay, so let's say you're trying to track down some performance issue, and it's like, okay, well, like when you're communicating with the database, like occasionally like you're seeing where sometimes it, you know, it executes within 2 milliseconds, which is totally fine, but sometimes it all of a sudden takes like 50 milliseconds. What you could set is like a threshold to say, okay, if this executes, if this event completes within, you know, in this case, 20 milliseconds, just ignore it. Don't include it in the recording, but if it takes more than that amount of time, then that event will actually be captured in there. So that way you're reducing a lot of the noise from what's happening in recording to where it's like, okay, I don't really care about the events that took a long time to complete, and only then those would be captured. There's a lot of different settings example, and you can kind of look in some of these configuration files to see that. But one really nice feature that was recently added, and this is if you've already been using JDK Flight Recorder, you might not be familiar with it. This was added in JDK 18, where you can actually call JDK configure, oh, not JDK configure, JFR configure. And so there's many different options. So like it shows you how you can configure a JFR file, and if you're unfamiliar with doing that, it provides you an interactive wizard where it will walk you through 12 questions on how to configure a JFR file, and it's also helpfully going to show you what the default settings look like, just so you know you're not going to accidentally say like, oh yeah, I'm just going to put it all on high and then, you know, explode or kill the performance on your machine. So like for garbage collector, you know, maybe it will capture detail information. But it'll always show you the whatever the default is, and you can also just enter through it as well to quickly go through the interactive process as well. But this is really nice because, as you can see here, this JFR or this JC configuration file, it is, I think, just over 1,000 lines long, and it's, you know, a whole lot of XML in here. So no one is going to go through line by line and look at this stuff. And so certainly at every organization I've been to before, it could be very easy to where like someone at some point puts together like a configuration file like 4 years ago, and you just keep on copying and modifying it over those 4 years because like, oh, okay, it just works, and there could be just a bunch of information in there that may no longer be relevant, or there might be, as I mentioned, like with every release, there's, you know, a few things being added to it, a few new event types that, without that being actually configured in here, you may no longer be you may not be capturing. So this new configuration tool is a really good way of, like, if you just want to get a new, good, clean JFR configuration file put together, you can quickly do that, and you know it'll be all set up correctly. So that way you're not going to have a bunch of potential magic within like your configuration files. If you already do kind of know exactly how you want your configuration file set up, as you can kind of see here, there's ways of directly passing configuration to a configuration file. Like here's like, okay, I want the GC set to high, I want method profiling set to high, and then if you don't actually set any of those other things, then we'll just set them to the default, and that way it's a little bit quicker. You not have to go through that 12-step process every time. As we saw also, like there's a bunch of events in there, and we can also have our own custom events. You can also, by using like the little plus symbol and the event name, also configure it to where enabling an event, configuring the behavior with that event as well, on how you want it set up. I will say also, one of the things, as I mentioned usually it's under 1% for the overhead for it. But one of the most costly things within JFR is recording the stack trace. So in this case, like we're setting the stack trace to 2, which I believe is to capture it. That is one area where if you increasing the amount of stack that's being captured, that could have the most significant impact on the performance impact from using JFR. Let's see. One thing I do want to show you that I forgot to mention earlier, just to also show maybe how JFR can like show you when things are going wrong in your application. So like let's say within your application, like you're suspecting like there could be like a thread, like some sort of resource leak, you know, memory, thread, or something like that. In this example, I will simply, oops. Come on. There we go. In this example, I'm just telling it to leak a bunch of objects that can no longer be captured by the garbage collector and removed. All right, and then I'll stop this application. Open it back up. And then here, if I went into memory, we'll see it's not super obvious or particularly obvious if you're not familiar with what heaps look like. But in this case, for example, there's a lot of memory allocated integers, which would be kind of very unusual to see. Most of the time, here we'll see like byte arrays at the very top. That is the underlying how information is stored for strings on a heap. So that would typically be at the very top of most heap allocations, just because strings take up a lot of memory, and usually, like I said, for most applications, like half or more of the heap is devoted to strings. But here we would see, for example, in this integers, where again I was setting up to where they can't be garbage collected. It's unusually high up in the application. Now, of course, it's probably not going to be often the case where integers are there, but if you're suspecting there's like some sort of class that you think is taking up too much memory or something that's happening, you can go in here into this memory analysis, and it can show you what's happening. And actually here, then you can see the stack trace of where this is occurring. So you can see here in the very well-named JFR controller leaked memory. It's probably not always going to be quite that obvious. You can see where those objects are being created, and then from there being able to begin to track down how that information to update your code to maybe so it won't be leaking resources. Whether again it's leaking memory because of objects not being able to be garbage collected, or connections to the database, threads, whatever it might be. This could be a good way of tracking down that information. Oh yes. So also then, actually I think it's already, well maybe not. Yeah. So here in this example, I am going to update the custom configuration file to include the new event type that I created that I showed a little bit earlier. And in this case, I'm just setting the threshold. Actually, I don't have to provide a threshold and I want to, but in this case, I'm setting it to where 0 milliseconds, so that means it's effectively going to capture everything. But if I then, once again, run this. So if I didn't provide a settings file like I haven't before, that means it's going to use the default settings. But here in this example, I provided settings, and then of course custom.jfc, which is what I set it to. When I do a configure file, you can also provide a specific name to the configuration file that you're setting as well. It doesn't have to be custom JFC. But if I run it again, and then actually have it set up to where in this, I'm doing this leak memory, that event's being fired a few times. And once again, I'll stop it. Go back in here. And if I go into the event browser, we can also then begin to see some of the benefits of providing like additional metadata information. So like here, like I provided, like I showed earlier, it's like PII, business, mission critical, and then like this is where the events would be located. So that's showing some of the benefits of providing metadata information. Another benefit though is, actually I'm kind of alluding to in here. So let's say within a recording file, we're capturing a bunch of information. Some of it might be personally identifiable, or there could be passwords, or something we don't want to share, but we maybe want to share the recording file. Perhaps we were thinking we found some sort of performance issue within a JDK, and we want to send a recording file to like the JDK engineers. And of course, we don't want to include personally identified information within it. In JDK 19, the new scrub utility was added to where we could remove selectively information from a recording file. I'm going to demonstrate how to do that. We can do something like this where, actually first, we can see, prove that what I'm saying is actually going to happen. So here, kind of using the JFR print to kind of quickly get to some information I'm looking for, if I was to do looking for PII events, personally information events, we get back several of those instances occurring with my application. But then if I was to call scrub, and I said, okay, exclude any category that includes PII, or any event that includes PII as metadata. And then I tell it to which recording file to do that scrubbing to. And then in this case, I also said, okay, write that file, the new file name to be recording no PII. So this recording file, it's not going to be changed at all by it. It'll just create a new recording file that includes it. If I didn't provide a name, then it would simply be the name of the recording file -scrubbed. But if I do that, and now if I was to then check into that recording file again, we get nothing back because that information has been removed. So, it could be good for both removing, again, potentially sensitive information, or maybe you can also limit it to, only specific information you care about. Like, okay, we really only care about what's happening in the garbage collector. There's ways you can configure it to where it will remove all that information, or you could do it to where filters could do exclude information or include information. So if you want to only get specific information, then you would do like an include filter. They can filter on categories, event names, and also different threads as well, like the thread IDs. So there's several different ways of filtering out information. Let's see. Yes?
So with the scrub, is there a heap dump in there? So is there memory, like strings? Because that would be more personal identifiable information than categories.
Yeah, so it doesn't do it based upon that. You can't be like, oh, look for something that looks like a SSN to remove that information. It is going by the metadata of the different events. That's kind of how JFR works, is all through that event typing. At least as of right now, I don't know, that may not change in the future. So most of the time, like the default events included within JFR probably won't be including too much in the way of personally identifiable or sensitive information. As you can kind of look through like the recording, and it's going to just be providing information like your garbage collector. Where the trouble could come is if like you have your own custom event types where you may be capturing some information that's happening within the business information that could be like, oh, usernames, because for some reason occasionally we're seeing where we're querying to a database, like some issues occurring. Like a good example, my colleague Jose, his name has like a accent above one of the letters, and maybe something doesn't support like Unicode, and that's causing it to explode. Obviously, we wouldn't want to necessarily include like customer names or something within the recording file. So it would have to be based upon categories, the event name, are the threads of not recording information. So you can't get down to like that specific level of not including certain strings. Yeah.
Right. So if I have the flight recorder running
Mm-hmm.
in production,
Mm-hmm.
and the service is running for a few months,
Mm-hmm.
what's the size of the file? Is there like something to consider in like picking up?
So you would want to set it. You would want in the recordings. Let's see. Actually, I'm not connected to the internet right now, so I can't go to the tool page. But I think I have links within it on the tool page to go to. There could be ways of like setting up chunks to be like, okay, once a file would reach 250 megabytes, to then shoot off to dump that information into a recording file. Yeah, if you're going to have a really long running process, you obviously want to set that again to whatever sensible file size, time. And I think you could even do both. So you could be like every hour dump the information, or if it gets to some amount, dump the information, and whichever is hit first, it would dump in. Yeah.
So the question is there an option to add system logs?
No, that would be separate.
And,
Okay, I'll get to you in a second.
the IDE, is there an IDE plugin, or do we have to use mission control?
So I think you can actually, so like as you can see, or if you're familiar, JDK Mission Control is obviously built into Eclipse. And I think, if you don't want to switch between separate JDK Mission Control and maybe your IDE, like I think Eclipse, I think you could actually have a plugin to use JDK Mission Control within it. Perhaps within IntelliJ, they also have some sort of plugin to do that. I don't know. I'm one of the few developers that still continually to use Eclipse. I don't actually use IntelliJ. But there probably is, to some extent, some sort of plugin for reading and recording files. I don't know to what extent, how well it's feature-rich compared to JDK Mission Control. Mm-hmm. No, absolutely, go ahead.
With streams, we discussed that earlier. Can I, from my computer, connect and stream, like if you want to, like the live stream?
Uh-huh. Mm-hmm. Yeah, yes, you could. And I mean, a lot of that would just be how you had that configured to be set up to like how you're where you're streaming that information to. Well, I guess this is over, yeah, so like you can have it stream over JMX, and then you can connect to a JMX port. So yeah, in that way you could have it like streaming remotely. Yeah. Yep. You had a question?
Yeah, on the sensitive data, like the II stuff,
Mm-hmm.
is there any reason why you wouldn't say hash the important value before storing this important value?
You absolutely could. There's absolutely no reason you could, when you're setting up like your own custom event to store this information, to do some sort of masking on that information because you don't want to show it or share it. Ultimately, like how this event is set up is entirely, our custom events are configured entirely up to you as a developer. But it just could be a case if for some reason you're capturing some sort of sensitive information within a recording file. The scrub utility can just be a way of easily then removing that, because as I mentioned earlier, it's like its own custom compact binary format. So it's not like you could just go in there and like manually edit it or something like yourself. You would need something like the scrub utility to actually remove that information. And one other thing with it, so that scrub utility was added in JDK 19, but it can work against at least older versions of recordings from like older, like at least I tried it on JDK 18 and it still worked. So like if you're also maybe running, I guess I haven't seen how far back it can go and still be successful, but like it's quite possible that if you're using JDK 11 in production right now and you had a recording file and you're like, oh wait, there's some information we want to take out, you don't have to upgrade to JDK 19 to use a scrub utility. You should be able to still use it against older recording files as well. All great questions, but it would be nicer if you could just do like search through and like, hey, if it looks like a name, like a regex or something, that would be nicer. But at least as of right now, that's not possible with the scrub utility. Yeah.
So the default metrics you get, what's the difference between those and like just the JMX metrics?
I don't know. Yeah, I've only maybe used JMX metrics a little bit from time to time. And I can't really give a good answer as to comparisons between them. So, yep. Yes.
So for applications you deploy to production, so let's say you're using like PCF.
So what you would need to do is set up some like location, like a S3 bucket or a volume or something like that to have that recording file to be dumped to. Actually, again, this is using Kubernetes just because everyone wants to be all cool and awesome about using Kubernetes. But this shows an example of how one company was doing using JDK flight recording to profile their applications in production. But yeah, long story short is they would take those recordings and they would tell them to go to like some S3 bucket, and then they were doing some other information like trying to combine recordings. Like, okay, they had like 4 or 5 applications all deployed, and they would do some sort of stitching together to be like, okay, these are all the recording files like that occurred, at this time period. So that way, when they're doing analysis on it, it would make more sense instead of like having to pull up a bunch of different JFR recordings from different locations and hoping, you're looking all at the same information. Because, if you're doing some sort of microservices and, service A and service B were having issues, having to match up exactly when that was happening manually could be very difficult. Yes?
There's a way to create a task.
Mm-hmm.
You can run some command line thing in there, and then send it to the container, and then it'll dump it in the logs.
Okay.
If you capture the logs, SSH logs
Okay. Yeah. So yeah, I've only used PCF like a little bit, and it's been years now. But yeah, there should be some way of like however place some way you're storing logging information. A similar way could be done for this as well. Also one other thing, unfortunately I don't have time to get into it, and I haven't done too much with it though. JFR can also, because of now the streaming utility, can also be used for doing unit testing. So one of the things that's really difficult when doing performance testing is like, okay, like, you're running performance testing on your application, you have to deploy it out, and you're doing it in your integration region or some whatever it might be. Your integration region might have fundamental differences from what's going on in production. So like maybe you're communicating with some sort of service, and you're in your integration region or your non-prod region, like maybe those services are in the same region, or maybe they're in different regions or something like that. That's going to obviously have very different latency than if it's different in production, and so any sort of like performance you get out of that could be fundamentally altered by that. Or maybe within your integration region, you're memory limited, but when you get to production, you're thread limited. So any sort of like optimizations you're making for memory might be an issue when you try to go to production. So what's interesting then, and a engineer from Red Hat, Gunnar Morling, put together the JFR unit. You can actually then use what's happening from JFR to kind of get an idea as to what your applications are doing. So like you're maybe checking to see like where you're making calls out to the database or something, you can have like a test around that to see how many events are firing, like how many times you're setting up a JDBC connection or something like that, for example. And what is preferable about this is that it only depends on the JVM implementation that you're using being the same as what you're using in production. Be like, okay, you know, if we're calling this up, you know, and some number of events are being fired, and you know, at some point later on, you can see that there's a significant difference in that, or the amount of memory being used, or whatever you're trying to check by. It should be much more consistent than it would be if you're trying to actually do on a deployed application, where, you know, as I described earlier, there could be a lot of different differences in behavior that's going on, or of course also like how long it takes something to execute. So all to say is that this could be a really good way of doing performance and regression testing, and something I'm going to hopefully dig into more here in the coming months, because I think it's actually a really interesting topic. Before I was super deep into automated testing, haven't done as much yet, but I knew one area that was really difficult was performance testing, again, for some of the reasons I mentioned. With that said, yeah, I guess we're right at about time. So again, if you have any questions, please ask them. And yes?
I think you said earlier that you don't know exactly how far back you can look into events.
No, you can look a lot farther back. It's just with the JFR scrub utility. It was just added in JDK 19, which was just obviously released earlier this month. And I just don't know how far back that scrub utility could actually work. So like, again, if you're using JDK 11 in production right now, I just haven't tested it yet to see if like you can actually still properly, you know, run the scrub utility against it to remove events and stuff like that. I just haven't touched that yet, but I think it should be possible. Yes?
So if you're using JFR, there should be no reason to ever take heap dump, right? Because all the information is in that same file.
I think so. I think almost like any information, yeah, in a heap dump would also be within a JFR recording. I guess I can't say for certain if there is some small differences, but you know, it's, yeah, you know, probably 99% of the time, you know, you're going to be able to get all the same information. So, yeah. Yes?
When you mentioned about the JFR unit test bits for the performance one,
Uh-huh.
test cases, does it show like the JFR metrics for each test case separately, or is it like?
I haven't worked with it enough to really know that. He has a video that I linked to where I think he demonstrates how it works, and so like you can kind of see how that would look. Yeah, I can't quite remember that. So I guess how it would show is from the streaming utility, you would pull whatever metrics you would want and have that be printed out within the execution of that test case to be like, okay, you know, it took this amount of time to execute, or you know, it took this much memory on the heap to execute it. So like in that way, it would be associated with each test case. I believe that's how that would be working within that. Yes? Uh-huh.
Is there something that Dynatrace cannot get its agent versus flight recorder?
I'm not sure. I haven't. I think some of them actually use JFR, like they build upon it to actually pull in. I think that's the case, but I'm not familiar enough with Dynatrace to really compare it to JFR to give like any sort of good answer. So sorry. Yeah. Oh, so.
I have a lot of experience with Dynatrace.
Oh, okay.
The agent uses all of whatever that is today to integrate into the JVM debugging hooks. The agent hooks into all that stuff,
Mm-hmm.
like a debugger. So if you're missing something in the agent that you can get in JFR, you should probably talk to your Dynatrace rep about that because you're paying for it.
Yeah.
Yeah, they don't like about Dynatrace is finding like that.
Yeah.
Yeah. I said, yeah. But it's one of the tools.
Yeah, you should be able to get one of these into Dynatrace because they're hooking the same APIs.
Yeah. Yeah, and one other thing, I didn't get to touch on too much to that, but like also with like the JFR scrub utility, there is also a programmatic API. So like if you're doing streaming, I think you can also have it to where you could have like streams that have been pre-scrubbed of information if you wanted to. There's also that case with like the streaming API, like there's a whole there's a whole API behind how you can set up to what information you're streaming out, and then, as I mentioned, how you're streaming it. And again, also with the events, there's also an API behind that as well to, how all that works, and how you can configure it. So, I kind of primarily showed it through a operational perspective, but there's also a whole programmatic perspective as well that hopefully I'll obviously be exploring here a lot more pretty soon, but don't quite have yet ready for this presentation. So. Yeah, but thanks everyone. If you have any more questions, please feel free to ask them, or if not, shoot me an email or reach out to me on Twitter. I'll be more than happy to answer them. So thanks everyone for coming.